Hello, everyone. Today I'm super excited to sit down with the founders of Progressive Robotics, a company that we just funded, or leading a seed round of 1.5 million euro. And we're going to talk about supply chain, logistics, robotics, sort of human labor, and how actually we move items, packages, boxes, products from A to B, which is pretty much the majority of the economy, right? So, guys, what made you make Progressive Robotics? What was the realization that you said, scrap everything, we're going to focus on this for the next part of our years?
So we started from the university. We spent a lot of time research doing a PhD in the university, where we developed technologies about robot control, machine learning, computer vision, and motion planning. At some point, we said that in order to make a true impact, we have to move this technology to the industry, focused on manufacturing and logistics. We decided to start the company when I met Mario, so we decided to start this trip together.
Yes, as what said, we met 7 years ago, and this was the turning point. When I finished my PhD last year, Fotis proposed to start this company and to bring this awesome technology to industry. Right now, we started from single scale palletizing because palletizing is everywhere. And
just to make sure for everybody that's watching, palletizing means we move, for example, the boxes on a pallet. So it goes from an industry output to a fulfillment center or to a grocery chain or whatever that is, right?
Exactly. And the reason we started with palletizing is, as Mario says, is everywhere. All manufacturing companies in the world, from small, medium, huge sizes, when they make products, they put them on the pallets and they need to start them on the pallets. This is currently an operation that is done mostly manually. And particularly for small and medium-sized companies that can't afford the automation of standardized robotic programming, standardized robotic automation, they do it manually. So it takes human, sometimes they need to stack boxes up to 20, 25 kilograms into pallets that are 2.4, 2.5 meters high. They have to climb, sometimes have to climb a ladder. It's a very tough job. Every couple of hours, they need to switch because it's very strenuous.
Strenuous, boring, and I guess people figured out how to optimally make the pallet must be kind of inefficient, right?
And the biggest problem is that nobody wants to do this job.
Of course.
And when we have gone to more than 100 factories and logistics centers. And when we ask them what is your main problem or why do you want to automate and put robots, the question is always the same. We cannot find people. So the labor shortage is a problem that is worldwide, is getting more acute, and at some point it will be very, very difficult for the jobs.
Okay, but we know like there's Band, there's Kuka, there's like a multitude of robot vendors. We're not talking humanoids, but we're talking about industrial robot arms, right? So the hardware is there. What is Progressive Robotics is bringing to the equation that helps all these customers?
So we provide the software, make these robots more versatile and more easy to use. When we have asked these customers, why haven't you put robots already? The questions vary a little bit, but they all boil down to the same thing. There's no solution. Every factory needs some sort of customization. They need flexibility, because very different, a huge variety of products. So the traditional way to program a robot is called a system integrator. Someone know how to program a robot, spend a few days, put a single recipes for a single product. So imagine if you have 100 products. So our customers have experienced a reduction in deployment time up to 80%.
Wow. And I guess before the lab you showed me that usually what integrators do is that they actually guide the robot from point A to B, and then they program or the Cartesian space where they tell the robot very exact details of where to go and pick something and where to go and leave it. Accurate?
Exactly. And this is what happened 40 years ago, and this is what happens today.
Wow. I will expect things to be more sophisticated, right? And I guess you do it, and then one of these boxes changes in size because it's a production line. You can't guarantee the same size and the same output forever, right? What happens then traditionally?
So you have a change in production or you have done a new product, you have to call again the system integrator. I was in a factory that had 3 robots, and when I went to visit the production floor, only 1 robot is working, and there are humans that are palletizing manually. And when I asked them, why has the robot broken down? They said, no, we just had a new order And we have called the integrator for the last couple of weeks. We're expecting them to program the robot. So until then, we have to do it manually.
Oh, that's crazy. And I guess the three robots were the same vendor or the same model, or they can be different usually?
They can be different. So our software is hardware agnostic. So we support different robots. All the major brands, KUKA, ABB, Fanuc. Of course, we support different end effectors, what you put in front of the robot, not just the suction, the vacuum cap, which is the, let's say, the traditional, but we support fork grippers, lift grippers, and so on. And of course, we support different hardware on the perception side cameras.
So far, we need the integrators to come in and program the robots, make sure that they address all the edge points, but different robots, different configuration, different corridors that are coming in, different boxes, and the complexity is astronomical. How do you make it easy for, let's say, an average frontline worker to actually operate a robot, since it seems like a science project for someone to program them?
In order to make this able for the production line worker that doesn't have any expertise with robots or create a new recipe for the robot, you have to first of all make it foolproof. So we have all the mathematics behind, under the hood, that allow the robot to make mistakes. So we have the 3D model and we generate automatically the trajectories of the robot. We don't leave this to human. The human only needs what type of box you need to handle and what type of pallet you want. And everything is taken care of automatically. So it takes less than a minute skilled operator to add the new recipe.
Yeah, and just so there's some very nice user interface that looks like games and easy for people to visually tell the robot what they want to achieve.
It has to be very simple because in the production floor it's very noisy. People are very anxious. They are running around all day. So they do things mechanically. So you have to make it very easy to use. The user experience must be very sleek. So you know what buttons you need to pull to push. If something changes or there's a warning and you have to acknowledge that the production line runs smoothly.
So, given all the complexity in the space, I guess you must be using artificial intelligence or more traditional ML in different places. Is this correct, Nico?
Yes, of course. We are focusing on mixed case palletizing right now. The next step is mixed case palletizing, which is the holy grail of robotics. So we use cutting-edge technology for decision making. So what is it? Mixed case palletizing. You have to put different boxes of different dimensions in a pallet. So it's like a 3D Tetris. You have to build a pallet to be stable, and you have to maximize the space above the pallet. So this is a very difficult problem, and we know how to apply machine learning in the more optimal way. So solve this problem.
What are some of the different AI technologies that you're using to achieve this?
Perception. First of all, we give the ability to the robot to see, so it can perceive its environment. But perception is truly difficult to apply in industrial environment and to play, let's say, 99%. So the difficulty behind perception is high quality data. So how in progressive robotics, we know how to utilize less data with better algorithms. So our team, we have an exceptional team of engineers, and we know how to use these algorithms solve the problem of perception. And of course, the other difficult problem that we are facing is decision making. The box that is coming right now conveyor, we know how to utilize, how to improve the state-of-the-art algorithms that have developed. And
I guess that makes also the operation of the robot more efficient than what human programming will do,
yes,
right?
of course. So right now we have seen that from our installations that the robot is running 20% faster than the traditional.
And on top of having to brake because people are tired or making shifts, and there's also this gain of being 20% faster because you make the movement of the robot more efficient and fully utilizing the physics of the robot versus having a very dummy arm that goes from A to B, from C to D.
Exactly. When you let the human on this trajectory manually, you know for sure that it's not optimal. But if you have a smart algorithm that's running back and calculates automatically what is the shortest way for a robot to go from A to B, which is not a straight path, it's actually so you can make things run very much more efficient.
That's great. What does the future hold for the industry at large in progressive robotics? We already see companies like or company like Amazon, like almost being or claiming to be fully automated in several fulfillment centers, but it's only Amazon with Amazon powers that can do that. What about everybody else?
If we focus on the logistics, globally there are 125,000 fulfillment centers. This number is growing by 10 to 15%. So the majority of these logistics centers, the operations on that. So if you want to automate fully a warehouse like Amazon, you have to do it from scratch. But is it feasible for all these warehouses to automate everything? I wouldn't say so at the moment.
Yeah,
so
definitely don't have the capacity to be fully integrated or use the same hardware and have like an army of PhDs in robotics that they're gonna do it for them.
Okay,
right?
so why don't we take over the heavy lifting? So which is the stacking. So why don't we put standalone robotic cells in the warehouse? So it can be in a semi-automatic way. So you feed them these robots in a way that you do it currently. But you let the heavy lifting to the robot. And this can be, let's say, you can put a fleet of robots over there.
It's like a fleet of humanoid robots, or you think industrial application will require industrial robots?
The thing is that if you have something very heavy, very even difficult for a human, it will be difficult for a human. Right? So,
but there is not there.
Exactly. At the moment, yes. So the heavy job, heavy lifting is good for a big industrial robot.
Before our talk, you alluded like to carts, robotic carts on wheels. Is this something that Progress Robotics will be pursuing in the future?
This is a vision for Progress Robotics, put mobile robot workers to automate more things in the factory, not just the stacking, but also running around the corridors, unwrapping pallets, selecting the boxes that you're going to put on an order fully automatically.
We're recording this video on the second week of 2025. We just announced the seed financing round. What's the plan for the next year?
So we have the single case palletizing program that we want to scale, and we are currently planning some pilots of mixed case palletizing. And also we have some open positions right now on robotics engineering, machine learning, business development to help us on the next steps.
That's great. If you're a robotic engineer or if you're an experienced business development space, we're hiring right now. You are attending some trade shows this year, is that right?
We will be in Automatica, which is one of the biggest trade fairs in Europe. And we also have plans for some smaller fairs in the US and Asia.
That's great. Thank you very much, guys, and congratulations for what you have seen so far.